Hey, this is Josh. We're going to be doing some of these problems for the chapter review. I figured what I would do is write down the first batch just to kind of get us started. So once again, you should have graph paper, you should have a pencil, and you should be working on these ahead of me because the first thing we're going to do is we're going to solve these ones graphically. Okay, now on a test, yes, you're going to be given a coordinate plane, so don't worry about having to draw your own graphs. Remember, we already had that discussion about how certain students, who I will keep anonymous, like to draw their own graphs and then do stuff like this, which is awful, and then they try to graph these things, and it's like, it's so hard to figure out, like, where is this line going, because they made the lines themselves. So what I always tell students is even if you're given graph paper, you know, use those blue lines like on the ones that we use or whatever color it is. Go up by 1, 2, 3. Excuse me. If you have really big numbers, then go up by like 2, 4, 6 or like 10, 20, 30, whatever. You know, you can do that, but just keep these values the same on both sides. All right. So we're going to graph all of these. If you want to pause the video and just go ahead and graph them and then see what you get and work ahead of me, I think that that's always a great way to do these. I'm going to be going pretty quick. It's the end of the chapter. You should know how to graph two linear equations. And I threw in a couple that were a little bit interesting. And so try them, right? This first one here, again, my graphs won't be perfect. They won't be super beautiful. I'm going to do my best because I'm just going to freehand them on here. I want to talk through them, and so make sure you understand the process, not just how to graph this stuff. Okay? So let me draw this guy here, and I probably don't need that many lines, but so be it. Okay. On all of these lines, we have a starting point, and then we have our rate of change, also known as the slope. Now this guy up here in this first set, there is no number next to the slope. So what have we talked about? Well, how many units of x are there? There's 1. And can I turn a 1 into a fraction? Yes. So these are all the little things that students struggle with in the test because they forget that they have these abilities and then they just kind of like sit there and get stuck looking at it, where if they just saw that one little hint, they'd go, oh yeah, I can totally graph that. That's easy. So we have two parts, right? We have our starting parts, and then we have our rates of change or slopes. And it's not as loud on this video, but I usually like to make these dots super annoyingly loud in class because I think it really brings everybody's attention to the fact that the sign or symbol in front of the number goes with it. And so my starting point for this, the y-intercept, is a +2. This is y, so I go up 2, right? Positive, negative. And then my slope is up 1 over 1. So I go up from my starting point. I go up 1 over 1 and make my other dot. Okay, draw my line and I'm good. The other one is a little bit tricky, and I wanted to include a couple of those because these ones you guys have gotten really good at. It's these guys that are always a little bit tricky. Now people look at it and they go, well, how do I know how to graph that? Is that a linear equation? Technically it is. It's an equation that creates a line, but it's a very different kind of line. Okay, and so when we have stuff like this, I always say if you're not sure because it's like 1 unit after like some letter equals, you know, whatever, then make a table of values. And when this happens, now I say that this is more of a rule. It's not really a formula, I guess you could say. And the rule says x equals 1. So if y is 0, x is 1. If y is 1, x is 1. Y is 2, x is 1. If I were to graph this, I would go over from the origin, right? Over 1, up 0. Over 1, up 1. Over 1, up 2. Over 1, up 3, right? And so my line, yes, it's an equation, right? It's creating a line, is going to go straight down like that. Now, the reason I'm drawing these out is because I was told to solve these graphically, right? And this is where if you need a ruler, use it, protractor, whatever. If you can't draw a straight line, then fix your situation, okay? It's going to be critical to solving these guys. And so if you drew these lines nice and straight, then they should cross right here. And let's see here, that's over 1, up 1, 2, 3, okay? And that's our answer. Can I check that? Yes. This is a value for x. This is a value for y. So I'm saying x equals 1. Does x equal 1? Yes. Could I plug in x over here as well? Yes. Right there. Okay? If I plug in a 1 here, 1 plus 2 equals 3. Okay? And so I could plug the 3 in right here, the 1 right there, and I just want to make sure this side equals this side. You don't need to be concerned yet with the actual numbers. Like you could get like 14 equals 14, negative 7 equals negative 7. The number value doesn't matter right now. All that matters is that the equation balances, meaning you get 3 on this side, 3 on that side. Okay? All right. So let me erase this guy. Now I'm going to kind of go through these guys and we'll see what you get. Like I said, hopefully you've paused the video just to kind of give yourself a chance, graph these guys, see what you get, and then we'll see if we match up. Let's see here. Again, my lines are, reasonably spaced apart, okay? I always tell people, this is not art class. I'm doing my best. I'm going to draw these guys out and then graph. So this guy is done. Okay, the next one here. My starting point is, again, I'm going to save you some of the dramatics and just kind of do that. And so my starting point is negative 3. All right, so I go down 1, 2, 3, make my first dot. My slope is 2, but I got to make it into a fraction. So I turn it into a fraction like that, 2 over 1, which tells me now that I'm going to go up 2 over 1 and make my next dot and then draw my line. All right, that's reasonably straight. And then I got my other guy here, y equals 5. Again, it's another one like this guy up here. And so if you're not sure, make a table of values, x and y. X is 0, y is 5. How do I know that? Because the rule's telling me that no matter what x equals, it's going to give me the number 5. X is 1, y is 5. X is 2, y is 5. So I go over 0 and I go up 1, 2, 3, 4, 5. Okay, and then I go over 1, up 5, 2, up 5, and I'm just going to go straight across. And it looks like my lines are going to cross somewhere right around there-ish, okay? Which looks like it's like over 1, 2, 3, 4, up 5. There we go, 4, 5, okay? I know that y equals 5, but let me plug in the x value here into this equation and just make sure that it works. And I'll put a 5 over here, right? Because y is equal to 5, I'm going to put a 4 here. Okay, so I have a 2x. So 2 times x, 2 times 4 is 8. 8 minus 3 is equal to 5. So bam, we got that one done as well. Moving right along. Hoping you guys are still safe. Hope everything's okay. Thank you for sending me jokes and all kinds of cool stuff and some funny things that have happened to you. I do want to keep things light in these lessons because, we're going through some crazy times. And even with my own kids, like we've started going through all these boxes of random toys and stuff in the basement. We're like, oh my gosh, what is this? And my 9-year-old, he got out this whistle. So, of course, he's walking around the house going beep, 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 all day long. I'm going, oh my gosh, this is going to make me crazy. And so halfway through the day, I was like, okay, I'm done with that thing. Like that thing is making me crazy. And so I gave him one last chance with that thing. And unfortunately, he blew it. Okay, well, hopefully that one was funny. Get it? Blew it, whistle. No. Okay. Anyways, let me get back to my math here because I'm hoping that one was as funny as I thought it was. X plus, why am I writing out the equation? Oh my gosh. See, I got all sidetracked because of these constant jokes, It's tough to be a person telling jokes and doing math at the same time. You should try this with the harder classes, man. Okay. Now I got 2 actual equations, so let's graph these guys. My first one here, my starting point is plus 2, so I go up to 2. My slope is 1, right? If there's nothing there, we assume it's a 1 because it's like 1 unit of x, and we can make a 1 into a fraction if we need to. Up 1 over 1, and we draw our line. And then I got the other guy here. My starting point is -1. My slope is up 1 over 1. And I'm going to draw that guy. And sometimes you don't notice, especially if the test says to solve your, solve your equations graphically. They're looking for you to graph both of these. Now, if you were like super on top of this and you're like, hey, I already noticed that the slope was the same, therefore these two lines are parallel, therefore they will never intersect, therefore the number of solutions for this is no solution. If that was your thinking and you did all of that, then that's awesome. Okay. And again, I know I just talked through that kind of fast, but you should have spent time going over the lesson. Was this an infinite solution, one solution, or no solutions? These first two had one solution because these two lines crisscross at a certain point. This one has no solutions because they have the same rate of change. So we have different y-intercepts and they're just going to kind of follow each other on to infinity and beyond. All right. And so now we got that guy done, and let's just keep on going. Okay, we got x plus y equals 2 and x equals -3. So let me just draw this guy out here. All right. I'm going to do this guy first just because it's easier, and then we'll talk about the top one. So x equals -3. Okay, again, I got one of those special ones, and I focused on those in this lesson because those are the ones, like you guys have all shown me that you can graph the basic ones with a fraction and a starting point. Those ones you guys seem really on top of. It's the little guys like this where you get all tripped up. So that's what I wanted to practice in the video. X is -3. What does y equal? I don't know, whatever, right? 0, 1, 2, whatever. X is -3, y is 0. X is -3, y is 1, 2, whatever. You'll notice you're going to get this straight-ish. That looks pretty good. You're going to get this straight-ish line like that. That's going to go up and down. Okay, and now I got this guy, x plus y. All right. Now, in order for you to graph these, I mean, you could take some shortcuts and do whatever you want, honestly. But in order for you to graph them, you really do need to have them in that y equals mx plus b format. So you need the y by itself, okay? Equal sign, that looks good. But you need everything else on that side of the equation. And you can reorder stuff using all those math properties and whatever. But the main thing is you got to move stuff across the equal sign, and in order to do that, you need to add or subtract. So because this is a plus x, we minus x. What we do to one side of the equation, we do to the other. Okay? So I end up with y equals 2 minus x. Is this in y equals mx plus b format? No. So I'm just going to reorder it so that it all matches up. Y equals, and now I'm going to move this guy up. But remember, whatever the symbol or sign is, I mean, I keep doing it every single time. Whatever symbol or sign that's in front of that value, whatever it is, a letter or a number, we move it together. So I have a -x plus 2. It's a very common mistake. First, people forget to subtract it, then they forget to move it to the front, and then they forget to bring the negative sign with it. So these are all my like hint, hint, hint kind of situations where you just got to take a second, spread your work out, and now we have y equals mx plus b format. My starting point is 2. My slope is -1, right? Down 1 over 1. And so this guy's going to kind of come down like that. Based on this, it looks like it's going to be, I don't know, my lines were kind of bad right here. I'm assuming it's -3, 5, but let's just check. Well, I know x is -3 because that's one of the rules. Let me plug in 5 for, what is that, 5 for y, and see what I get. Y is equal to 5, x is equal to -3. Does -3 plus 5 equal 2? Yes. Therefore, this is the solution, and this is the point of intersection where these two lines criss and cross. Okay, So I feel like that's enough of these ones. The last set of problems, I want to do a couple of them, are the ones where you have to solve them algebraically, okay? Which is really not too tricky. You just, again, you've got to take your time with some of this stuff. People just go rushing through it, and as a result, they make small mistakes. Now, the nice thing is with a lot of these problems, it isn't too hard for you to check your own work. So I always say, like, you know, when I do that extra step and I plug the XY points, like where they crisscross, I take that ordered pair, I plug it back into both equations and make sure like 9 equals 9, 4 equals 4. I make sure I do that last step. Unfortunately, on tests, a lot of students skip that step because they're thinking, no, I graphed it perfectly. This has got to work. It's nice having a way for you to be able to turn in the test and know which ones you missed because you solve them algebraically and or mathematically and graphically. All right, so these ones here, let me just kind of make sure I got a screen up. We're going to solve these ones algebraically. I got my first one here, which is y equals negative x plus 10 and y equals 3. I got 7x minus 5y equals 3 and x equals 4. And then I got, let's see here, I got 5x plus y equals 8 and negative x plus y equals negative 4. Again, pause the video. If you can do all three of these ahead of me and check them as I go, dude, you're rocking this stuff. That's awesome. I'm going to do the first one here. Okay, this one is pretty quick, and we had one of these in the last video. If y is equal to this and y is equal to this, then I'm allowed to say, well, then 3 is equal to whatever the other guy is, negative x plus 10. Now, could I just eyeball this and say, oh, well, what number, and what negative number plus 10 would get me to 3? Could it be like 4, 6, 7, 8, 9? I mean, it's got to be some number around there, and it can't be too big because I'm ending up with an answer of 3. Could I just start plugging numbers in and figuring it out that way? Yes. Okay, but you're not really solving it the algebraic way, which is so important because yes, you could eyeball this, but the minute I start throwing in fractions, mixed numbers, square roots, decimals, dude, you're going to be here forever trying to pick out like what the answer could be. I would much rather you look at this problem, solve it algebraically, and have a pattern or method that you can use. That way, when you go back and do them again, you can go, okay, it doesn't matter what kind of number this guy gives me because I know the system to solve this thing. Okay? Oh yeah, and these are called systems too, because we got two things happening. That's kind of funny. Okay, anyways, moving right along. Let's get all our x's on one side, our numbers on the other. This side has the x, so I'm going to move the number back, or get it out of here. All right, so, that's a 0. And then 3 minus 10 is negative 7. And now I have negative 7 equals negative x. I don't care what negative x equals, just like I don't care what 10x equals, right? I want to know what x equals. 1 unit of positive values of x. I don't even know if that said that right, but that's okay. 1 positive unit of x is equal to something. The way we get rid of this, now some teachers will say, well, if you have a negative here and a negative here, you just erase them both and they cancel out and you're done. But it's not really exactly what you're doing. Okay, mathematically what you would do to get rid of this guy is you would multiply this side by negative 1. Because negative 1 is not going to change a value, but the negative sign is. A negative times a negative is positive. A negative times a negative is positive. So I know it looks backwards, but that's okay. We can leave our answer like this. If you want to flip it around, you can. I'm looking for an ordered pair answer though, because it says in the book, and that's what I'm reading from here, solve each system of equations algebraically. Tell me where these two lines crisscross. Okay, well these lines would crisscross, this and this guy would crisscross at ordered pair x equals 7, right? It's always in order, it's always x and then y. X equals 7, y is 3. That's what I would want as the answer. Yes, your work is correct. Yes, you've shown me a lot of good stuff, but I would not give you full credit if you didn't put them together and show me that you understand that it actually is creating that point of intersection. Okay? So make sure you're up on that as well, because it shows up all the time. People do this awesome math, and then at the last second, they kind of drop the ball. All right. Okay, so now I have one here. I got 7x minus 5y equals 3. And you know what? I'm going to put that one on top. X equals 4. Again, if you think you know what to do, work ahead. I'd rather you do this problem on your own and get it wrong and then go, oh, that's right, I messed up on that one little thing, versus watching me do this, right? This is not edutainment. This is you participating in the lesson. I know you're sitting at home, probably eating some nachos, like your laptop's right here, and you're like, oh yeah, dude, I'm doing the math. And then you're like, not even doing the math. So take a minute, right? I'm doing it. You might as well follow along. You're going to get more out of this stuff, and you're going to need to know this next year. These are all applicable to Algebra 1. X equals 4. And then I got this crazy formula over here. Okay, I need to solve for y, and I was told that x equals 4. And so the first thing I would do is I would take that number and I would use that one rule, if you want to call it, and substitute in to this equation this value. Now, anytime you have a number and a letter next to each other, it means multiply. So let's do it. 7 and a 4. 7 times 4 is 28. Minus 5y equals 3. I'm just rewriting all the same stuff. Okay, get the value or the variable by itself, move everything else to the other side. And again, if you need to pause the video, if I'm going too fast, then just take a second and pause it. That's okay. Negative 5y equals 3 minus 28 is negative 25. And now let's just finish this guy off. Negative 5 times y. We always do the opposite, right? This was a positive 28, so I did negative 28 to get rid of it. If I have something being multiplied here, I do the opposite of multiply, which is divide. Negative 5, I divide both sides by negative 5, and I always read my fractions down. So y equals negative 25 divided by negative 5. Again, if you're not sure, grab your calculator if you're allowed to use one and plug all this in. You know, maybe you're not good with negatives. Maybe you don't know what 25 divided by 5 is. Who cares? If you have that tool or you're allowed to use it, go for it. Negative 25 divided by negative 5 is 5, right? The negatives cancel. That gives me a 5. Okay, I know x is 4 and y is 5, so according to Josh, this is what I need to do. If I have all this amazing work, that's great. It's not full credit because I didn't answer the question, which is where do these guys crisscross? They cross at 4, 5. Now, could I graph these lines and prove it graphically as well? Yes, but we're not going to be doing that just yet. Okay, right now, you're just going to be asked, solve it graphically or solve it algebraically. I mean, I guess you could you could do both at the same time, but for now, I think you're going to, at least on this test, it's going to be separated. So as long as you can do them, you're all set. So like I said, we were digging through the basement, going through all this stuff, and we have all these things in the house. And, you get kind of stir crazy just being inside all day. And so, being me, I was making jokes, with my wife and everything. And let me start writing this guy out here. 5x plus y equals 8. Negative x plus y equals negative 4. Okay, so, I'm telling her jokes throughout the day. And she's like, oh my gosh, that's so bad. And then I'd tell her another one. I'm like, what about this one? And she's like, oh my gosh, that's so bad. And by the early afternoon, we go on this 10th walk of the day just to kind of get out of the house. And she's like, you need to stop with these awful jokes. And I thought, well, you know what? Let me put this back on her. And I said, well, how do you expect me to do that? And she says, whatever means necessary. And I looked at her and I said, no, it doesn't. You might need to go back and rewind that one. That's a good joke, man. I hope you like that one because I thought that was pretty funny. And then I went like this because I thought she was going to throw a rock at me or stick or something. But that was an interesting part of our day. Okay, let's solve this guy algebraically as well. We're wrapping up this lesson and then we are done. Okay, now when it comes to these, you have a couple different options. The goal is to take one of these equations and move everything to one side except for one of the letters. So that way you can then substitute into the other equation, right? Kind of like the previous one. I took, this guy had x equals and then stuff. So I plugged that stuff into the other equation to solve. I kind of have two choices here. I could move the 5x over, or I could move the negative x over. Either one is going to work. So it really is up to you how you want to solve it, okay? Let me first, I'll move this guy over and we'll see what we get. So I subtract 5x and I get that, right? It's not in the right order, so I'll just turn it into the right order, negative 5x plus 8. Now, what I need to do is say, okay, that's what is equal to y, right? Y equals that. So anywhere in this equation where I see the letter y, right there, then I plug in that stuff. And so what I've done is I've kind of eliminated all of the y values, okay? So let's do that. I got negative x, and for some people, they like to draw the 1 there just because it helps them see, oh yeah, let me make that a little bigger. Like that, I got negative 1 unit of x. And now I'm gonna fill in all that other stuff. Minus 5x plus 8 equals negative 4. Combine like terms, negative 1x plus negative 5x is negative 6x plus 8 equals negative 4. Now let's move this guy over, minus 8, and so I get negative 6x equals negative 12. And again, if I'm going too fast through this part, just pause the video, watch it again, see what I'm doing. I'm just adding and subtracting to combine like terms or to move stuff side to side. Negative 6, I divide both sides by the same thing. What you do to one side, you do to the other. Negative 12 divided by negative 6 is 2. And you might be like, Josh, like, okay, you got 1, but what about the other one? Like, how am I supposed to figure out the other answer? Okay, well, now let's pick one of the equations and plug it back in to solve for y. I don't know which one is going to be easier, actually. I'll just pick the top one, whatever. We'll put it right here, right? X equals 2. 5 times 2 is 10. So I end up with 10 plus y equals 8. Let's use our math. Could I say to myself, 10 plus a certain number is going to give me 8, negative 2? Yes. But again, follow the pattern, follow the steps, because that's what you're going to need next year in algebra. And if you have these patterns already in your head, when I add, like I said, square roots, decimals, big old numbers, you'll go, okay, I already know the pattern and I have a calculator, so it really doesn't get much more difficult. Minus 10 from both sides, right? Because I'm going to do the opposite, and I get y equals negative 2. So I've done it mathematically. And so now I'm done. I have 2 and negative 2. I write it out as an ordered pair, and I'm done. Okay, so let's go the other route because I just want to show that that's going to work as well. Okay, so let me erase all this. You know what? I'm just going to rewrite the whole thing because I think that's just going to be faster. Let's see here. 5x plus y equals 8. Negative x plus y equals negative 4. Okay, we're going to move this guy over. So I get y equals x minus 4. How'd you do that, dude? Well, I plus x'd to both sides. Or plus x, yeah. And did that. And then I just turned it around and made that. So again, if I'm going too fast through that part, just remember, all I'm doing is adding and subtracting. I'm doing the opposite to move stuff side to side across that barrier or equal sign. Okay, now I have this. So this guy can get plugged in right there. I end up with 5x plus x minus 4, right? Because I just insert it, equals 8. 5x plus 1x is 6x minus 4 equals 8, plus 4, 6x equals 12, x equals 12 divided by 6 is 2, okay? And now I have my x value, right? I got the same number, so that's awesome. Now it's a matter of plugging it into the other equation, or one of the equations, to solve for y. So I know I went kind of fast through that, but some of these skills we've been practicing all year, and if you still don't have them, now is the time, okay? You're going to be using this adding and subtracting, moving stuff side to side. I think I've said this like 10 times in this video, but you know, as a teacher of algebra and pre-algebra, it's like I know where you're headed with this stuff, and I know how crucial it is. And if you can lock this stuff in now, you will save yourself some headaches next year. Okay, so practice how I did that. Understand what I'm doing. And then if you get better at this whole like plugging stuff into other equations, that's another big part of Algebra 1. Who cares if it's a decimal or square root or fraction or whatever? If you know what to do or you understand the reasoning behind it, that's what's important. Okay. So these were the last 2 sections of the chapter review. Take your time, ask me some questions if you have them. Keep sending me jokes, send me information, let me know what's working, what's not. I'm trying to cover the basics of all of these topics. You know, this remote learning thing is super crazy. So just keep putting in the effort and doing your best, and you'll get this stuff, all right? Once again, thanks for watching. See you soon. Tune in again, and we'll do some more math, all right? See ya.